Hi, everyone. Today's lesson is on the unit circle, converting degrees to radians and radians back to degrees. So let's get started. Okay, so we're going to start with a warm-up. This warm-up is something similar to what you did in geometry at the end of last year, and you were looking for arc length. Now, I know when we start in geometry, you are talking about angles and you're dealing with this angle inside here. And then in Algebra 2, what we've started to do in Trig Advanced, what we've done is we've talked about an angle that basically starts here on our initial side and then it goes around the circle this way, okay? Then today, what we're going to talk about is something called arc length, okay? Arc length is the actual distance or length around our unit circle. Now, depending on how much of it we're talking about, all the way around the unit circle, which was what we call the circumference. So circumference equals 2 times pi times r, r being my radius. In this case, let's say my radius was 5. Okay, there's 5. I would have 2 times pi times my radius, or 10 pi. Okay, and that would be my circumference. That means that if I were to walk around my circle, okay, the distance all the way around my circle, my walking distance, okay, that value all the way around my circle is what we call the circumference. Now, if I just want to talk about a portion of that distance, let's say I'm talking about 60 degrees of that circle. I want from here to here, only that distance from here to here. That's a length of the arc. We call that arc length. Now, in geometry, you might have used this formula: arc length is equal to the arc degree over 360 degrees times 2 pi r. And 2 pi r, meaning that's the circumference, this value right here being a fraction of the circumference. And so what that means is little a is here. That's the arc degree, which is actually this degree measure from here to here. They're like an arc degree instead of an arc length, which is your your length. It's a distance. So what you would do is arc length equals, now if I'm talking about 60 degrees, which I am actually dealing with pi over 3, ask yourself, pi over 3, thinking of my circle, if all the way around is 2 pi, then from this distance to this distance would be 1 pi, okay? And then, of course, this would be half a pi. So a third is a third of the way. So it's kind of like if you divided this up into thirds, okay? Well, how much is a third of this distance? Now, this distance right here in degrees is 180 degrees. But if I were to take a third of my length of pi over 3, 3 goes into 180, 3 divides into 180 60 times. So this angle would be actually 60 degrees. So pi over 3 is equal to 60 degrees. So arc length, so that's going to be arc degree, which is 60 degrees, divided by 360 times 2 pi r. R being 5, which is what they gave me. And so I would say this cancels into 1/6. So that would be 1/6 times 2 times pi times 5. And let's see, 2 divides into 6 3 times, actually. And so what I have left is 5 pi over 3. And so that's my arc length for a 60 degree or pi over 3 radian length. Now, we also have this formula, which is an alternative to what I just did, actually. And so S, meaning my arc length. So that basically means the arc length formula. So arc length is equal to theta, which in this case is in radians. So that would be pi over 3 times my radius, which is 5. So much quicker, 5 pi over 3. And so that's my answer for the arc length, which is the same value, just done a different way, different formula, different way. So again, this is just reiterating the circumference of a circle. If the radius is equal to 1 in this case, then my circumference would be 2 times pi times 1, or my circumference would be just 2 pi. And so what that is the distance around my circle is 2 pi. So let's just break this up again. This would be 0. This would be 1 pi. Okay, this would be a half of that. Keep going, this would be 1.5. Now, we don't write 1.5 radians, or 1.5 pi. We don't write it like that. So instead, you would write 3 pi over 2. And then, so that's 1.5 coming back up, which would be 2 pi. Now, if I wanted to say, what's the number for this value? Well, we know pi is approximately 3.14, right? So we would start at 0. So starting at 0, you would go, well, this is about 1.57, 3.14, et cetera. And you would go all the way around, 2 pi being approximately 6.28. And where that would show up on, let's say, a sine wave would be something like this, where you would start at 0. Remember, sine starts at 0, goes up 1, passes through 0, goes back down, comes back. Here's 0. 0 degrees, 360 degrees. Same thing with this is 0, not 0 degrees, 0. This is 2 pi. Well, 2 pi is 6.28 approximately. This would be pi, which we would approximate that as 3.14. This would be half of that, which is about 1.57, et cetera. And you can fill those in. Okay. So on the unit circle, provided mark the following angles. Well, 45 degrees, again, you always start with your initial side here, and 45 degrees going up here to 45 degrees is right here. So that's a 45 degree angle. Keep in mind that 45 degrees, if this is 180 degrees, right? And I were to divide this into 4 parts, 45 degrees. So we have 1, 45, 2, 3, and 4. So basically 45 degrees is equivalent to pi over 4 radians. 45 degrees is equivalent to pi over 4 radians. Now pi over 6, now again, if I'm looking at pi being 1 or a whole, and that goes from here to here, that's pi, okay? All the way around is 2 pi, but this is halfway around 2 pi, which is 1 pi. Now pi over 6, there's 2 ways to think of it. You're dividing this top part into 6 equal parts. Well, this top part is 180 degrees, right? So basically, I'm taking 180 degrees and I'm dividing that by 6, and I'm getting that as 30 degrees. So pi over 6 is this angle from here to right here, which is 30 degrees. 30 degrees is equivalent to pi over 6. 2/3 pi would be something that you would think, again, 2/3 is less than 1, and that's pi. So from here to here, that's 1 pi, okay? So 2/3 is not quite 1 pi, but it's actually 2/3 of the way over. So if you think of this, and I like to ask you to try to figure out some of this in your head, 3 divides into 180 degrees 60 times. So we know that we're breaking these up into 60 degree intervals. Now, so like here's 60 degrees, and then another 60 degrees here, and then another 60 degrees. Oh boy. And so when you're doing this, you're going to get 2 pi over 3. So we're going over 2 pi over 3. 3 goes into 180 60 times, but don't forget you have to multiply by 2. And so what really that is 60 times 2, which is 120 degrees. So there's 120 degrees. So this is equivalent to 120 degrees. That was equivalent to 30 degrees, and this is actually equivalent to pi over 4. So negative 3 pi over 4. So negative 3 pi over 4. Now that's different because remember, you start on the initial side here, right? But because it has a negative sign in front, that means we're going to drop down. Now this is still pi, but in this case, it's now negative pi because we're going down this way, okay? But we're going down 3/4 of the way over. So we're going from here down 3/4 of the way. A couple of things that you can think of, and that's negative 3 pi over 4. So that's going to be this distance right here. Now, keep in mind that this is, in degrees, it's negative 180 if I'm dropping down this way, right? So 4 goes into 180 45 times. So really, 45 times 3, meaning I've got a 45 here, 45 here, and a 45 here. Well, 45 times 3 is 135. So this is actually equivalent to negative 135 degrees. 240 degrees for this one. Think about this. This is 180 degrees. 180 degrees stops here. That's 180. Now, what's 240 subtract 180 degrees? So how much more do I need to travel? So you would subtract, borrow, you get 60 degrees. So we're going around this 180 degrees plus another 60 degrees. Okay, plus another 60. So from here, positive, going around this way, okay, is 240 degrees positive. How much of that do you think is a radian? Let's try to figure that out as a radian. Now, from here to here is 1 pi, all right? And then keep in mind, this was a sixth, 1/6, a fourth, right? If we keep going. And then this last one is a third, pi over 3. So from here to here is pi over 3. Because remember, if it's pi over 3, 3 divides into 180 60 times. Okay, so therefore, we're actually going 180 degrees plus another 60. All right, so really what we're doing is we're going pi plus another 60 degrees, which is your pi over 3. And meaning this was 180 degrees plus another 60 degrees, which gave us the 240 degrees. So this is 1 1/3 pi. So 1 1/3 pi. But again, we don't write that as a mixed fraction. So we're going to write that as an improper fraction. So 3 times 1 is 3 plus 1. So that's 4/3 pi. So 4/3 pi. That's my answer. Cool. All right. 3 pi over 2. So let's do that one. That's 1 1/2 pi. Okay. Keep in mind, we don't write them as a mixed fraction, but you can rewrite that just to look at it and say, okay, what does that mean on a unit circle? So where would that be? Again, start at your initial side, 0 degrees, and we're going to go around 1. And this is not degrees. So this would be starting at 0. So we're going around 1 pi. So this is 1 1/2. So this is pi. Keep going, but we're not going all the way around to 2 pi. We're going 1/2. So 1 1/2. Here we are. Where are we? Okay, that's where we're at. So we are at 270 degrees is where we're at. Okay. 7 pi over 3. 3 divides into 7, let's see, 2 times and 1/3 pi. Again, what that means is I'm not going to write that like that, okay? That's just going to give us relatively where are we. So we're going to go 1 pi, past that, 2 pi, now I'm here, and now I have to go up a third. Now remember, 3 divides into 180 degrees 60 times. So that means we went around 1, 2, and then a third. Well, a third of the way up is right here at 60 degrees. So this is where we're at, okay? And I guess another way of writing that is 2 being 360 degrees plus 60 degrees, which is 420 degrees. So that's equivalent to 420 degrees. 11 pi over 6 is 1. And let's see here, 5/6 left. Again, don't write it like this, okay? That's just giving you like a location where you are. So again, start at your initial side, and you're going to go around 1, okay? There's 1 pi. And now I'm going to go 5/6 away around. I'm going to keep going 5/6 around. So ask yourself, 180 degrees divided by 6 is 30, right? And what that means is you can look at that 2 ways. I'm going around once, and now I'm 5/6. I'm 5/6, meaning I am 1/6 short of, I'm 1/6 short of being 2 pi. See, it's really close. So I'm 30 degrees less. So basically what that's telling me is that value is 30. 30 degrees is my reference angle. So what is this equivalent to? Well, I'm in the fourth quadrant, okay? And I went all the way around, stop. I stopped right here. So I'm 30 degrees short. So that would be what? 330 degrees. So that's equal to 330 degrees because all the way around is 360. Now, another way of writing 11 pi over 6 actually is to drop this down. You know you're a sixth short. You could also say negative pi over 6 or negative 30 degrees. If they ask you for like maybe a positive or negative, another negative way to write that. So this is just talking about distance or lengths. We've been doing that. 360 degrees equals 2 pi. So basically, you could draw a unit circle like this, where going around, you've got your circle, all right? This is 0 degrees, and it's also 2 pi radians. So meaning, and it's also 0 radians. So this value going up to here is what, 90 degrees, or we call that pi over 2. Keep going. Here we are here at 180 degrees. We also call that pi. Keep going. We're at 1.5. So that's 3 pi over 2. And that's also what, 270 degrees. And then keep going around. We're at 2 pi, or we also could call that 360 degrees and so forth. Okay. So a lot of this, we've been doing this in our head. We've been like converting degrees to radians. There is a really cool formula. This is it. Okay. This formula converts radians to degrees and degrees to radians. You can change the X and move that around. I don't do that. But you're welcome to. And what that means is I could do this. Let's say I'm talking about, let's say pi over 3 radians. And I want to know, what is the degree equivalent to pi over 3 radians? I want to know what the degree would be. So for me to do that, I could use the formula right here, or I could use common sense and think, okay, well, pi over 3 is a third of the way around my circle. So if this is a third of pi, okay, 3 goes into 180, how many times? 60 times. So pi over 3 is 60 degrees. Okay, now that's doing that in your head. Now you can use this really cool formula instead and say theta equals 180 over pi, and then x being the radian, you would put that here times pi over 3. And so pi's would cancel. 3 divides into 180, 60 degrees. And so therefore 60 degrees is equivalent to pi over 3. Okay, likewise, you can go backwards. And for example, I can say, well, I don't know, what's 120 degrees? So I'm going to plug in 120 degrees in the degree slot. And I'm going to go, okay, I still have that equal to 180 divided by pi x. So in order to get x by itself, because ultimately I am trying to find the radian value, what I would do is I would multiply by the reciprocal of 180 over pi. So let's do that on both sides, of course. 180 over pi, the reciprocal of that, that's what I meant to say. And so we have pi over 180 times here, pi over 180. These cancel, and make 1, 1, 1, 1. X equals 120 pi over 180. Now, I'm pretty sure I can reduce that. Zeros are going to cancel, divide by 10. Then I'm going to have 12 divided by 18 pi. I'm going to divide by 6. So that's going to be 2. That's going to be 3. So my radian value is 2 pi over 3. So that's 2/3 pi. And again, I try to teach my students that it's not necessarily that you need to do that to use this formula, although it is very cool and very handy. You can just use your brain, which is good. And 120 degrees would be in this corner here, and you're asking yourself, If this is 120 degrees, how do I get back to the x-axis? My reference angle being 60 degrees, okay? And so therefore, 60 divides into 180. So 180 divided by 60 is 3. So that's my third. That means that's a third. I am a third of the way from here to here. From pi to here, I'm a third of the way, which means that for this to be this whole distance as a whole, therefore this is 2/3 of the way there. So that would be 2/3 pi, which is what I got. So you could do that in your head, or you can not. I mean, you can use the formula. We're going to use the formula because I want you to get used to this, because it doesn't, you don't always have an exact value. Like this, 3/4 pi. I mean, let's do that one. That one, 3/4 of the way around, that's pi. From here to here, pi. But this is 3/4 of the way. So what you're going to do is you're going to go 3/4 of the way. Remember, anything that divides it by 4, okay, is going to be, let me use this color. So that's a fourth, that's a fourth, that's a fourth, and that's a fourth. So basically, this being 90, this has to be 45 degrees, right? So anything that's a fourth is a 45 degree. Well, if I'm going 3/4 of the way over, that means I'm 45 degrees short. So I'd go 180 degrees minus 45 is 135. So therefore, this is 135 degrees. Now, you don't have to think of it like that. I mean, you can use your formula, which is theta equals 180 over pi times x. So this is my x right there. That goes there. So you would go theta equals 180 over pi times 3 pi over 4. Okay. Pi divided by pi is 1. 4 divides into 180 45 times, and 45 times 3 is 135. And so that's my answer. Okay. 3/5 pi radians. And I want to make that into degrees again. Now, that is not an exact value. So let's see, what is that? So let's do that. So let's say theta is equal to 180 divided by pi times x. X is 3/5 pi. Okay. Well, pi's are going to cancel and make 1. 5 divides into 18, 36 times? And then what's 36 times 3? 18, 108 degrees, not an exact value. So this one was a little bit tricky in that it was in our benefit to use the formula because that wasn't on our radar. The next one, 120 degrees, converting that to radians. Think of this like this, 120 degrees in your head. 120 degrees is in the second quadrant. You have a 60 degree reference angle. 180 divided by 60 in your head is 30. Or, 180 divided by 60 in your head is 3. And so therefore, this distance from here to here is a third, which means that this distance from here to here is 2/3 of the way over. So this would be 2 pi over 3. Now, using the formula, you're going to go theta equals 180 over pi times x. This is going to go in my degree slot. So that means that I'm going to go theta, which is 120 degrees, equals 180 over pi times x. Flip it around, you have pi over 180 times, you have pi over 180. Pi's cancel, 180's cancel. You get x equals 120 over 180. Zeros are going to cancel if you divide by 10. And then let's see here, what does this become? Divide by 6, so that's going to be a 2. That'll be a 3, so I get 2 pi over 3. And it's the same answer, just different way to do it. Now this one, negative 200 degrees, look at it. What is converting that to radians? Now what we have here is we're dropping down from here because it's negative, and we're going past 180 here. And so actually what we're at is a 20 degree reference angle. But what would be this negative value in radians? So again, I'm going to use the formula, and I'm just going to use theta equals 180 over pi times x, and theta, and this degree is going to go here. So negative 200 equals 180 over pi times x. I'm going to multiply by the reciprocal, which is 180 over pi, parenthesis, 180 over pi. And so I'm going to get this rather large number over pi. And I don't know what that value is, but it looks like it's negative 360. Let's see here, 0, divided by pi. And so whatever that value is, that's my radian, okay? Find a positive and a negative angle coterminal, meaning coterminal means ends in the same place, with 2 pi over 3. So one way I could do that is figure out where's 2 pi over 3. Well, that's right here, all right? 2 pi over 3 is 120 degrees, okay? We just talked about that. Now, what I could have done is to go all the way, I could go another positive value, is to go all the way around and come back, meaning I can go 2 pi plus 2 pi, sorry about that, 2 pi plus 2 pi over 3. Well, that's 2 and 2/3 pi. Again, don't leave it like that. That's going to be 6, 7, 8/3 pi. And so that would be a coterminal positive angle. To find a negative angle, one thing I could do is to go backwards this way. That's 1 1/3, right? Because if this was 2/3 pi, I can go around and that's negative pi and then 1/3. So that's negative 1 1/3, which is negative 4/3 pi. And of course, you can come up with an angle for that. If that's a 60-degree angle, that would be what, negative 240. Okay, now this question is a little bit different. Now this question is asking for the complement and the supplement. Okay, now the complement is two angles that add up to be, the complement is two angles that add up to be 90 degrees. 90 degrees, or what we call pi over 2. A supplement are two angles that add up to be 180 degrees, or pi. So for this case, if I'm at 1/3, okay, which remember is 60 degrees, there's 1/3, I want a complement. Complement, what do I need? What is needed left to get to 90 degrees, which is pi over 2? What do I still need? Now, if you're not sure, you can go pi over 2, which is what I'm trying to add up to, subtract what I have. What do I have? I have pi over 3, and try to get a common denominator. Well, in this case, I would multiply this by 2 over 2, and this by 3 over 3. And so that's going to be 3 minus 2, which is pi over 6, which is the leftover distance. So the complement would be pi over 6. Now the supplement is to add up to be 180 degrees. Well, this is pi over 3. So what's pi minus 1/3 of that? Okay, so that should be 2 pi over 3. So that's what's left. So now you have a complement. This is my supplement. This is my complement of those two angles. So this is the unit circle song, and I actually want to show you this because I really think that this helps you learn the unit circle song. So we're actually going to take a minute and listen to this. This is from my friend Michael Bautista, and it's found on YouTube as well. So here we go.
The unit circle, radians and degrees. I forgot to study and my A's went down to B's. I forgot the top half goes from 0 out to pi. I forgot it all and that's no lie. Think it goes like pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6 pi. Radian's an angle and a radius is a line, and if you study every day you'll do just fine. I forgot the unit circle trigonometry, sine, cosine, and tangent, and those trig identities. I forgot the lower half goes from pi until 2 pi. I forgot it all, and that's no lie. Think it goes like 7 pi over 6.
Hey.
5 pi over 4. 4 pi over 3. 3 pi over 2. 5 pi over 3. 7 pi over 4. 11 pi over 6. And then that brings us to the end, which is 2 pi.
Pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4,
5 pi over 6 pi, 7 pi over 6 pi,
5 pi over 4,
4 pi over 3, 3 pi over 2,
5 pi over 3, 7 pi over 4, 11 pi over 6, and then 2 pi degrees.
0, 30, 45, 60, 90, 121, 35, 150, 182, 10, 225, 242, 70, 300, 315, 330, and then 360 is the end. And now I hope that unit circles in your mind.
Okay, so I really love that song. I think that it is a great song for you to learn and to just listen to over and over again. And it will help you because here we are with our unit circle. And if I was to go around my unit circle, I'm going to be adding this in different ways. So let's say I'm going to talk about radian angles. And so I want to start with 0, not 0 degrees, 0. And then we have pi over 6, pi over 4, pi over 3, pi over 2. Then what? Then we go around. That's 1 going backwards. We can say that that's pi. We have 3 pi over 2. Coming back, we have 0. We have 2 pi. Okay. Coming here, we have, now remember, this is 120 degrees. So that's going to be 1/3 plus 1/3, which is 2/3. Now, one way also to remember this being 3/4 of the way around, so that's 3 pi over 4. And then this value here, almost pi, it's 1/6 short of pi, being 5 pi over 6. Now, memorizing this is one thing, but also being able to figure this out and counting all the way around. And let's just look at this, the 45. So this is 1/4. This is 2/4. 2/4 pi is pi over 2. Then we have 3/4. Then we have 4/4. This middle line here, that's 4/4. This would be 5/4. Okay. And then keep going. This is 6/4. 6/4 pi is 3 pi over 2. And then this would be 7 pi over 4. So, and then this, of course, would be 8 pi over 4. And that's our 2 pi. Okay, so that's counting by fourths. Again, 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. Counting by sixth, okay, sixth, you got 1/6, 2/6. Now 2/6 is 1/3. 3/6, which is a half, 4/6, 5/6, and then 6/6. Therefore, this is going to be 7/6. This value is going to be 8/6 pi, but keep in mind I can reduce that. And 8/6 is going to be 4 pi over 3. So that's 8/6. This is 9/6. Again, 9/6 is 3 halves. This value here is going to be 10/6 pi, but what's 10/6? Divided by 2. That's 5 pi over 3. 10/6. 10/6. 11/6. 11 pi over 6. And then this is 12/6, which is 2. Again, so counting all the way around, it could be helpful. And then also filling in the degree measure as well. This right here is actually a really great unit circle. You can get several of these off the internet, but what you do need to know is this quadrant right here. And this quadrant being all important because it mirrors itself in all of these quadrants with the exception of the positive and negatives. Okay, all of these angles here, all of these are exactly the same points with the exception to the positives and negatives. And what that means is this. Remember when we were doing the last problems, we were doing a 45 degree. and this is a little bit, yes, I know that's kind of tricky to see, but what we were doing was we were saying, okay, if you have your angle and you have your 45-degree angle, this point we write as cosine of the angle, comma, sine of the angle, okay? Which basically means if this was 1 square root of 2, sine would be 1 over root 2, which is root 2 over 2. Cosine would be the same, root 2 over 2. Now, the point is that in every quadrant for 45 degrees, for every single one of these, you're going to see that the core values are all root 2 over 2. And what that means is they're all going to be root 2 over 2, except for, remember our mnemonic that said all students take calculus? In the first quadrant, root 2 over 2, root 2 over 2 is going to stay as root 2 over 2. In the second quadrant, only sine is positive, which means, remember how it goes sine and then, cosine and then sine? Well, sine is positive, but this value is negative. So this value here at 45 degrees, which is a reference angle, which is basically 3 pi over 4, that would be negative root 2 over 2. In this quadrant, only tangent is positive, which basically means sine and cosine, this is cosine, and sine are both negative. In this quadrant here, only cosine's positive. So this is positive, whereas sine is going to be negative, root 2 over 2. So this mirrors itself all the way around. So how many of you have memorized that sine of 30 degrees is a half? So this is a half. At 30 degrees, it's a half, okay? So what that means is that, well, cosine is then root 3 over 2. This is, in every quadrant, this is the same thing for a 30-degree reference. The only difference is that the signs are different. In the first quadrant, they're both positive. In the second quadrant, only sine is positive, which means cosine is negative. So that'll be negative root 3 over 2, comma, 1/2. In this quadrant here, both sine and cosine are negative. So that'll be negative root 3 over 2 and negative 1/2. In the fourth quadrant, cosine's positive. So that'll be a positive root 3 over 2 and a negative 1/2. Okay, I hope that helps. So what I'd like you to do here is possibly pause the video for a minute and try to practice these answers, okay? So if you pause it, great. And then I'm going to get started on this now. Our job is to find the exact value of cosine of all these values. So cosine of pi over 6. Now, it is not a bad idea to draw a little axis for every one of these problems if you need to. 11 pi over 6. Think about that. Where's 11 pi? So that's 1 and 5/6. That's 1 and 5/6. So if you think about, we're in radians. So this is 1 pi. So this is 1 and 5/6. Now 6 divides into 180 30 times. So cosine of a 30-degree reference is going to be root 3 over 2. However, in this quadrant, in the fourth quadrant, cosine is positive. So that is positive, root 3 over 2. Secant, 5 pi over 6. So draw a little axis, 5 pi over 6. This is a whole. So we're a sixth short. Now 6 goes into 180 30 times. Again, a 30-degree reference. Now, secant is a reciprocal of cosine, okay? Cosine in this quadrant, remember 30, so this would be 1, 2, square root of 3, but this is negative. If cosine is adjacent over hypotenuse, then secant is hypotenuse over adjacent. And then, of course, we wouldn't leave our root on the denominator. Our final answer would be negative 2 root 3 over 3. Then for the next problem, okay, let's see here. We have 19 pi over 6. That's 3 and 1/6 pi. Okay, so drawing my little angle, my little arc here, I've got 1, 2, here's 3, and a 6th, another 30-degree reference. Cosine of 30 degrees is root 3 over 2. But in this quadrant right here, all students take calculus. That's our mnemonic for that. Only tangent's positive, which means this is negative. Okay. Cotangent of 7 pi over 4. That's 1. 4 goes into 7, 1 and 3/4. So let's figure that out. So here we go. 1 and 3/4 of the way. Okay, so 44 is 45 degrees. So you've got your 1, -1, and then your square root of 2. Now, tangent is opposite over adjacent. Cotangent is adjacent over opposite. So 1 over -1 is -1. 3 pi over 2 is 1.5. So this is going to be over 1 and then a half. Here I am. Where am I? I'm at 0, 1. That's that point right there at 3/2. Cosecant is a reciprocal of sine. Now, if sine is 1 over 1, flip that over, 1 over 1, you still get 1 over 1. So that's 1. Oh, excuse me, but this is negative. Thank you. So this is negative because it's 0, -1. Okay, sine of 10 pi. So for this one right here, you actually have to figure out, well, where are you in this? 10 pi, just start counting. This is 1 pi, 2 pi, even on the right. 3 pi, 4 pi, even on the right. So if I keep going around, I'm going to get 10 pi right here. Where am I? I'm at 1, 0. Well, what's sine? Remember how it goes cosine, sine? Well, I'm at 0. Sine of 2 pi over 3, so 2/3 pi is here. 3 goes into 180 60 times. There's my reference angle. Sine of 60 degrees is √3 over 2. And in this second quadrant, all students, sine is positive, so my answer is going to be positive. Tangent of -3/4. So remember, be careful because you got to drop down because it's a negative. So we're going to drop down 3/4 of the way. This is negative pi. 3/4 of the way down, we're at a 45-degree angle. Remember what tangent of 45 is? Opposite over adjacent. So that's going to be 1. In the third quadrant, where tangent is, right here, where our reference angle is, all students take tangent is positive. So my answer stays there. And the last one, cosine of 21 degrees, count. So we start here at 0. Not 21 degrees, I'm sorry, that says 21 pi. So starting at 0, there's 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, odd pi here. So here's odd pi. So we're here. Where are we? We're at -1, 0. Remember how it goes cosine, sine? We're at -1. So my answer is -1. So, okay, find each of the values again using the unit circle, pi over 3. So divide 3 into 180. 3 divided into 180 is 60 degrees. So we're here at 60 degrees. 3 pi over 4, excuse me, tangent of 60 degrees. So tangent of 60 degrees, make a little triangle, 60 degrees. 2, 1, square root of 3. Tangents, opposite over adjacent. So that's not 60 degrees. That's pi over 3. Thank you. Cosine of 3 pi over 4. So now I'm in the second quadrant. 3 pi over 4. Okay. Cosine is going to be √2 over 2. However, being in the second quadrant, only sine is positive. So therefore, cosine is negative. Cotangent of pi. Now this one's a little bit tricky. Here's pi. Pi is -1, 0. Okay. Cotangent. Now we haven't done any graphing yet, so I would show you on graphing what this looked like. But remember what tangent of pi is equal to sine of pi divided by cosine of pi. That means that cotangent of pi is going to be cosine of pi, which is -1, divided by sine of pi, which is 0. 0 underneath, 0 in the denominator means that our value is undefined, which basically means where that value is, there's an asymptote there. And I guess I could show you what the graph looks like. A cosine graph or a cotangent graph does this, and it comes like that, okay? Basically, this is 0, and this is pi, and there's an asymptote there. Okay, so sine of -pi over 6. So 6 goes into 180, 30 degrees. So I'm dropping down 30 degrees. Sine of 30 degrees in any quadrant is a half. But the positive and negative will be dependent on what quadrant I'm in. I'm in quadrant 4, so therefore, all students take calculus, only cosine is positive. Only cosine is positive. So that means sine is negative. And cosecant, remember, that's the reciprocal of sine. That's 1 over sine. So basically, let's figure out where we are for this angle. Negative 7 pi over 2, negative 7 pi over 2. 2 divides into 7 3 times. So that's negative 3.5, which basically means we're going to start here at 0 and go down 1, 2, 3, and then here I am at a half. Where am I? I'm at 0, 1. Now, sine of this value is 1. But remember, cosecant is the reciprocal of sine. So if this is 1, what's 1 flipped over? 1 over 1, still 1. Okay. Okay. And that's it for today. Thank you.